About React compiler at Meta. So we're going to talk about how the compiler performs and pit it against apps at Meta. But first, we need to see what these apps even look like. Ooh, I got to update. Somebody did not update their operating system. Oh, I can't click away. I have to click update now. Ah, thank goodness there's a conflicting application running. We're back. Okay, but anyways, so we're going to talk about how these React compiler performs on these apps, but first we're going to need to talk about what they even look like. So let's first talk about their code. We noticed that React code at Meta can be mapped neatly onto 2 dimensions. On one axis, we have how fast or slow the app itself feels. How long does it take to repaint the page when I hover or click a button? On the other axis, we have readability. How concisely does the code describe business logic or what's shown on the screen? And just so we're on the same page, you want to be here. Fast interactions and easy to read. Now, a lot of the code that we see is in this quadrant. Most React code at Meta is pretty easy to reason about and also performs well. But on pages that have a lot of interactivity or just even a lot of components, for code that describes complex bits of UI, we find that developers start making trade-offs. Complex apps that haven't been optimized with use memo and use callback tended to be a bit slower, but stayed easy to read. And a small sample of the code that we saw was pretty difficult to read. This code contained a lot of manual optimizations, which helped make the UI feel snappier, but they also made the code much more difficult to reason about. This is all a bit abstract, so let's take a look at one of these samples. So this is an actual, real React component from our code base. I had to rename some of the variables for legal reasons, but please trust me, some poor engineer at Meta actually needed to write all of this to describe their UI. And just to repeat, this is a single function, one component. We're not going to read any of this code, but I want to show you why it takes so many lines to describe this logic. Let's Control F to search for every call of use memo and use callback. Wow, that's almost 20 places where that developer hand-optimized an object. I also want to see how much of this code on the screen is spent just describing memoization. So let's also highlight the dependency array arguments. Oof. So all of the code in red that only exists to describe how to avoid recomputing values. And finally, I want to see how much of the business logic had to be wrapped and passed to use memo. This reflects how much cognitive overhead it takes to edit the core logic of this component. Oof. So now that we've kind of drawn this graph and written these axes, I'm going to tell you about the real meta apps represented here. This highlighted point we've been talking about, with the super long piece of code, that comes from a React Native app called Quest Store, the app store for Meta's Quest VR devices. Meta engineers spent a really long time hand-optimizing Quest Store because of how dynamic and interactive it is. For example, take the product details page, which I'm showing here. I've already bought Beat Saber, so I get a button that says download instead of purchase. And I can click or scroll with my headset controller through the left panel for different detail types, which might also differ across games. Now, you might also recognize another very dynamic, highly interactive React app built at Meta, and that's Instagram.com, a pretty complex website with a lot of hand optimizations. In 2023, we began rolling out React Compiler on both of these apps. Now, I originally had some boring stuff here, like how we resolved to roll out without rewriting any code, and how the compiler avoids cheating by removing memoization that developers wrote. But let's just get to the fun part and talk about some results. The rollout was a success. React Compiler has been enabled on Quest Store and all of Instagram.com as the default experience. So if you've browsed for any Quest apps or used any part of Instagram.com in the past couple of months, you've almost definitely been using React Compiler. In terms of performance, we measured that for some click and scroll interactions, the compiler-optimized version was more than twice as fast as before. We also saw initial load and cross-page navigation times improve by up to 12%. And finally, we observed that there was no impact on either memory usage or overall crashes, which may reflect out-of-memory errors. This improvement didn't apply to just a few pages either. We observed that Quest store loads and navigations got faster by at least 4%, and Instagram saw an average 3% improvement across every route. At Meta, this was a really big deal. I mean, to put these numbers in context, engineers had combed through every single bit of these apps to add thousands of memoization calls. And of course, this work was done against metrics, which rewarded in the scale of every single optimization. On such an app, improving just a single thing, something like the time to first paint of a specific page, by just 1 or 2% would already be a huge deal. But React Compiler had significantly improved the performance of nearly every page it rolled out on. So how did the compiler do it? What did it do differently from all of these hardworking engineers? Let's take a look at that code from Quest store again. Now I'm going to draw some white boxes to show places where React Compiler was able to add memoization that wasn't already there in source. We see that even on such a heavily optimized function, the compiler can still find additional opportunities for optimization. On less optimized apps, we found that React Compiler can add over 15 times the amount of memoization already present in source. The best part? Developers can now go back and delete all of this cruft without affecting the performance of their app. Yeah! So what this all means is that with React Compiler, developers will be able to get fast interactions on apps that haven't been manually optimized and improve the readability and maintainability of already optimized ones. In fact, we've just seen how React Compiler can even raise the ceiling for just how fast apps can be, as it can optimize much more than developers can with nested and conditional memoization, as well as sophisticated static analysis. Since proving out the core of the compiler last year, we've continued to roll out to even more apps to iterate on the compiler and, of course, the development, debugging, and testing experience. You may recognize some of these. To talk about what's next for the compiler, I'll hand you back to Joe.
Good job.